Okay, let's begin. Hello, everyone, and thank you for joining this stream on Sustainable Maritime Operations. My name is Afshin Mansouri, and I'm chairing this session. I'm a professor of operations and supply chain management at Brunel University, London, and also principal investigator of the EU-funded project PortForward at Brunel, and a work package leader for one of the work packages of the project on sustainable operations and green scheduling. Today, we are going to have three esteemed speakers from the three EU-funded projects as part of the Port of the Future network, which is a European funded network of 4 projects started from 2018 with a total funding from the European Commission of in excess of 16 million euros. One of the projects has already ended, DockstheFuture, and today you are going to hear about the visions of the 3 projects and their vision in making operations research and operations research management science methodology, data science, in making the Port of the Future greener, smarter, and more sustainable ecosystems. The first presenter will be Cihan Butun, our colleague at Brunel University PortForward team, who is going to present a talk on the Green Yard scheduling. Title is The Green Yard Scheduler. The second talk is by Irene Schoss, co-authored with Stefano Persi on multimodal freight transport planning and prediction, which is part of the COREALIS project. And the third talk from the Pixel project by Erwan Simon is titled Supply Chain Modeling as a Transversal Tool, Port Activity Scenario Model. Before starting our talks, I'm going to give a few housekeeping notes. During the talks, if you have any questions, please type them in the question and answer box that you can see in your Zoom ribbon, and I will summarize them and ask at the end of each talk. You can also share your view about any question by giving it a thumb up, and the question that gets the highest thumb up will go automatically to the top. So I will notice it and try to start by asking questions which have more favorite views. And at the end of the 3 talks, if there is any time left, we can continue our discussions and answer any remaining questions. Please note that the whole session will be recorded, including the comments that are posted. And the copy of the recorded video will be made available after some editing by the OR Society to the participants and to the wider public. Everybody who can access the conference website can see and view the recording of the call. And I would like to wish you all the best and enjoy the session.
Okay, so good afternoon, everyone. Let me first introduce myself. I am Irene Schoss from MOSAIC Factor. MOSAIC Factor is a startup based in Barcelona, and what we do is big data for mobility and logistics problems. I am an industrial engineer, and I'm working here as a data analyst, and I'm currently working in different H2020 projects, and one of them is COREALIS. Today I'm gonna talk about what we are currently doing in COREALIS, which is a solution for multimodal freight transport planning and prediction. But first of all, I will tell you a bit about this project. So COREALIS is an H2020 project that proposes an innovative framework supported by disruptive technologies, including IoT, data analytics, traffic management, and 5G networks for cargo ports to handle future challenges as the traffic efficiency and sustainability. The project has a duration of 3 years. It will end in April 2021, and it received a funding of around 5 million. In the consortium, we have different key players from the port ecosystem, and all the COREALIS innovations will be tested in different ports, in which we call the living labs. And we have the Port of Antwerp, Port of Valencia, Port of Piraeus, Port of Jamina-Kotka, and the Port of Livorno. In our case, our solution will be tested in the Port of Antwerp, which is the second largest point in Europe and one of Belgium's biggest economic driver. The challenges that is facing Port of Antwerp, as well as many other European ports, are in terms of making the mobility more efficient, to achieve a sustainable growth, also dealing with data sharing to increase the operational management, and to go into the transition of green ports and ports connected to cities. So, well, when we were designing this proposal, while we were talking with the Port of Antwerp, we wanted to design a solution that provided an optimization of the operations of the port. So we designed the cargo flow optimizer with the objective of increasing the percentage of utilization of sustainable transport modes, such as rail and inland waterways, after the container arrives to the Port of Antwerp. So by using and analyzing real-time data from the port, the cargo flow optimizer tools will offer shippers the optimum route and will predict the container's destination. So, as I said, to accomplish these objectives, finally we decided to develop 2 different tools. One is the Multimodal Inland Planner, and the other one is the Cargo Flow Prediction, which they are 2 different tools that they can work separately, but both of them have the objective of optimizing the port operations. So first of all, I will explain what's the Multimodal Inland Planner. The main goal of the Multimodal Inland Planner is to give a complete overview of the most efficient connections between the port and its hinterland by rail, barge, and truck. So it calculates the optimal door-to-door container routes between the Port of Antwerp and another port terminal or any destination in Europe. And this optimization of the routes is in terms of distance, the estimated duration of the trip, price, and the CO2 emissions. So, well, this is a beta version of the tool. And here the user can define the shipment needs and can enter the destination, also with the container characteristics and the desired date of departure. And afterwards, the tool will compare the available routes from transport operators that operate in the Port of Antwerp and will present the most relevant ones, optimizing the costs, the routing, and the ecological footprint. This is also very useful for shippers because up to now they didn't have a solution where, I don't know, like we have Google Maps when we want to see where to go. they usually had this information in different databases, in like also calling and so on. And this is a way to have all this information together and makes it easier to provide optimized routes in terms of, as I said, emissions, price, and duration of the trip. Then we have the second tool, which is the cargo flow prediction. In the case of Port of Antwerp, the road transport is responsible for more than half of all the freight traffic operations. This means that most of the operations go by truck. And in order to achieve this vision of future ports and green ports, and to improve the management of the logistic resources of the ports, it is very important to understand how the container traffic flows work. So this means that knowing the frequencies and the volumes of the container arrivals and departures for each of the transportation modes is essential. So the main goal of this tool is to predict the multiple cargo flow using historical information and the daily traffic of the containers from the different transport modes between the port and the European hinterland. This task has a high complexity, as the fluctuations in the economic activity are quite high, but also the nature of the logistics sectors, where the quality of the data is not the best or the one we could wish. So, what we did with the cargo data we had from the Port of Antwerp and the daily traffic data, we developed several models in order to test the prediction and to capture the performance of the boundaries. We tested some different models like Sarimax, and we tried some classical models, but also with artificial intelligence. And then the best option we found is to follow an artificial intelligence approach with artificial neural networks, specifically with the multi-layer perceptron. So what we did was an exploration and data analysis of and time series analysis of the data we had. We tested these different models and evaluated them. And now what we have is with this multi-layer perceptron model, we have the daily prediction of the containers and their destination, and also which mode of transport, and up to 1 week. It's daily prediction, and we predict the next 7 days. Well, that was everything. I just explained the two tools in quite high level, but if you have any questions, I'm here to answer, and also maybe my colleague Emilio can also join or answer them on the chat if they are more technical.
Thank you very much, Irene. Very timely presentation, very concise and informative. There is one question already from the audience. I start off by this. What forecasting models are you using?
Yeah, we tried different ones. The one we had the best performance was the multi-layer perceptron with, let me check, I cannot remember now. Yeah, the multi-layer perceptron with one hidden layer.
Okay, thank you very much. The next question is the model planner available online?
Yeah, the idea is that it's available online. Now it's online, but you need a user and a password that only, well, people from COREALIS project can use it. But the idea is that we can publish it online after the end of the project or when we have like a more robust version.
Okay, thank you. And the last question, what features are you using for the predictor? Is it mainly time series based or also dynamic features?
Well, it's time series, but also with the dynamic traffic, with the real-time traffic. This prediction is updated every day. But one of the things, well, we analyzed and so on was if it really made sense to give a really detailed prediction, I don't know, like hourly prediction, and for the characteristics of the ports, the prediction that it made more sense was a daily prediction. So it's not like very, very dynamic.
Okay, thank you very much, Irene, for your responses.